Have you ever just stood outside, looked up at a clear night sky, and thought to yourself, are we really alone out here? Well, welcome to This Explainer. Today, we are cracking open the ultimate cosmic detective case. We're going to explore the incredibly profound and honestly sometimes a little unsettling insights from physicist Brian Cox regarding the search for alien life. We're diving right into the collision of cosmology and biology to try and understand why, when we look out into a universe literally teeming with possibility, we are met with absolute deafening silence. Get ready because the numbers behind this mystery are going to blow your mind. Okay, let's dive into this. Our very first massive clue is 400 billion. That is the upper estimate for the number of stars blazing across just our home galaxy, the Milky Way. Just the Milky Way. And we know now that almost every single one of those stars is likely orbited by planets. The sheer, unimaginable scale of our own galactic backyard is almost impossible to wrap your head around. But, it's not just about the raw number of stars out there. It's about what orbits them. Which brings us to another wild number, 60 billion. A recent study suggests there could be roughly 60 billion planets sitting perfectly, comfortably in our galaxy's habitable zones. That's the Goldilocks zone where it's not too hot, not too cold. The basic ingredients for life, things like liquid water and energy, they appear to be incredibly common throughout our galaxy. It's like the universe is basically one giant chemistry set. Now, add to those ingredients the element of time. 13 billion. That's the timeline of cosmic history we are working with here. The universe has been around for nearly 14 billion years total, which means there has been plenty of time, we're talking billions of years, for ancient civilizations to rise, evolve, and figure out things like interstellar travel. With all these stars, all these perfectly habitable planets, and all this immense time, we should be literally tripping over alien artifacts, right? And yet, here is the dramatic plot twist of our cosmic mystery. Zero. Despite the billions of stars, the tens of billions of potentially habitable worlds, and the billions of years of cosmic history, zero is the exact number of alien civilizations we have found concrete, undeniable evidence of. All of our astronomical observations, our massive telescopes, our radio listening arrays, they have all turned up absolutely nothing but silence. So, this eerie silence brings us to what's known as the Fermi paradox. It's named after the brilliant physicist Enrico Fermi, and it essentially boils down to three simple words. Where are they? I mean, with trillions of planets and over 10 billion years of history, it is completely reasonable to ask why a civilization hasn't arisen, say, a billion years ahead of us. Why hasn't any civilization managed to escape its homeworld and essentially write its existence across the stars for us to see? Well, let's look at the possible solutions to this paradox. Let's transition into the first hypothesis of our cosmic mystery. Think of this as suspect number one, the machine expansion. See, when we think about exploring the galaxy, we shouldn't necessarily be thinking about biological beings flying around in spaceships. We really need to frame this around artificial intelligence and the frankly terrifying power of exponential growth. This brings us to physicist John von Neumann's concept of self-replicating machines. Imagine an AI-controlled 3D printer. You send it to an asteroid. It uses the raw materials there to literally build a replica of itself. Then both of those machines launch to the next star system, mine more materials, and replicate again. Brian Cox points out that calculations by physicists John Barrow and Frank Tipler show that even with reasonably basic technology, these machines could spread like a virus. If someone had launched them even just a few 100 million years ago, these probes would have exponentially grown to cover the entire galaxy by now. But we don't see them, so why not? Well, that brings us to the absolutely terrifying concept of the Great Filter. This theory suggests that the laws of physics create universal bottlenecks that make it incredibly hard for life to survive long-term. Now, is the filter in our past? Maybe making the jump from single-cell microbes to complex multicellular life is just phenomenally, unbelievably rare? If so, hey, we're the lucky ones. Or, as Carl Sagan theorized, is the filter actually in our future? Think about it. When civilizations industrialize, they inevitably discover things like nuclear physics, or they massively alter their climate. We suddenly gain the power to destroy ourselves, which, let's be honest, is a test humanity is currently taking. If short-lived civilizations routinely self-destruct, it perfectly explains a silent universe. Now, of course, people have come up with other explanations for the Fermi paradox, things we can affectionately call extraterrestrial excuses. Take the zoo hypothesis, for example. This suggests aliens are basically treating Earth like a protected wildlife exhibit. But as Brian Cox humorously notes, zookeepers try usually hide from the animals, right? Plus, they'd have to be doing an impossibly perfect job of evading our increasingly powerful telescopes. Then there's the super popular idea of government cover-ups of UAPs. Cox points out that historically, human governments are simply way too incompetent to keep a secret of that magnitude for any real length of time. The more people who know a secret, the faster it leaks. It's practically a law of nature. But wait, what about distance? Could they just be out there, but the journey is just way too far? Well, physics doesn't actually forbid intergalactic travel. According to Einstein's theory of special relativity, if you travel at 99.99999% the speed of light, the distance to the Andromeda Galaxy shrinks by a huge factor of 7,000. It's a phenomenon known as the gamma factor. Literally, from the spacecraft's perspective, the distance physically compresses. However, the technology required to accelerate anything with mass to that speed is, from our current scientific perspective, virtually impossible. And that leads to a fascinating realization about what an alien might actually be. Popular culture loves biological aliens, right? Bipedal beings that look pretty much like humans with some forehead makeup. But honestly, that's just a relic of 1960s TV budgets. Biological beings are incredibly fragile and require insanely complex life support systems. If an advanced civilization is crossing the cosmos, they have almost certainly moved past biology. They would likely be digital aliens, immortal, silicon-based AI, built perfectly to endure the absolute harshness of interstellar space forever. So the aliens we're looking for might not be biological organisms at all, but highly advanced, practically immortal machines. Because those interstellar radio signals have proven so elusive, scientists are now shifting the narrative focus much closer to home. We are currently conducting a really tangible scientific search right in our own cosmic backyard. Let's zoom into our solar system for a minute to see where the real hunt for extraterrestrial biology is happening today. So let's look at our prime candidates for a true second genesis. First up, we have Mars, which hosted actual flowing rivers and oceans about 4 billion years ago. The Perseverance rover is physically there right now, taking core samples to hunt for ancient traces of life. Then there's Europa, a moon of Jupiter that harbors a deep, active subsurface saltwater ocean beneath miles of ice. Exciting missions like the Europa Clipper and the European JUICE probe are gearing up to investigate these exact conditions. The profound implication here is that biology is ultimately just complex chemistry. If we find microbes that originated independently on Mars or Europa, well, it proves that life isn't some miracle unique to Earth. It would mean the universe is absolutely teeming with life. But of course, there is a catch. Just look at the cosmic timeline. Earth cooled down and formed about 4.5 billion years ago. Microbial life emerged almost immediately after that, around 4 billion years ago. So starting life, seemingly easy. But look at how long it took to get to us. It took another 4 billion years for human civilization to finally arise. That is roughly a third of the entire age of the universe. This strongly implies that while basic chemical life might start quickly and easily under the right conditions, building the incredibly complex ecosystems required for actual intelligence, that is astonishingly hard. Furthermore, you need a highly stable environment for billions of years to allow that complex evolution to happen. And that brings us to a major problem: red dwarfs. These are by far the longest-lived and most numerous stars in our galaxy. But they are surprisingly hostile to complex life. Because they are so dim, any planets have to orbit very, very close just to stay warm. But that extreme proximity causes the planets to become tidally locked. That means one side always faces the star, literally roasting in perpetual daylight, while the other side is frozen solid in eternal night. This makes those long, stable, evolutionary timelines required for intelligence even rarer than we might hope. When you combine the vast, stretching timelines, the hostile stars, and the sheer, almost impossible difficulty of evolving a brain capable of grasping all this, you begin to realize just how incredibly special we might actually be. Brian Cox often references this genuinely beautiful thought from Carl Sagan: a physicist is a hydrogen atom's way of learning about hydrogen atoms. Just think about that for a second. 13.8 billion years of cosmic evolution, starting with absolutely nothing but simple hydrogen and helium, has somehow beautifully arranged itself into beings capable of looking up at the sky and understanding their own origins. It is a breathtaking miracle of chemistry and physics. So where does this leave us? What is the ultimate verdict of our explainer today? Well, Brian Cox's takeaway is a pretty sobering one. Updated models of the Drake equation, which is what scientists use to estimate the number of active, communicative extraterrestrial civilizations, suggests that on average, the number in the Milky Way right now might literally be one. Just us. We cannot rely on benevolent aliens coming down in silver ships to save us from ourselves. We must behave as if we are entirely alone. It makes the survival of our civilization not just a human priority, but a cosmic imperative. As we wrap up this explainer, I want to leave you with one final, kind of provocative question to chew on. Are we the only candle of consciousness left in the Milky Way? If the great filter lies ahead of us and humanity fails to navigate the extreme dangers of our own technology, would our self-destruction extinguish the galaxy's light forever? It is a really heavy thought to stare at the ceiling and ponder tonight. The universe is incredibly, unfathomably vast, but consciousness itself might be incredibly rare. It's entirely up to us to keep the candle burning. Thanks for joining me on this deep dive into the cosmic mystery. Keep looking up and keep asking questions.